On December 27, 2024, astronomers witnessed something they had never seen before. A robotic telescope network in Chile detected a fast-moving object whose orbit didn't just raise concern, it triggered panic. The calculations were stunning. This wasn't a routine near-Earth asteroid. It carried the highest impact risk ever recorded in human history, a number so alarming that planetary defense teams worldwide were immediately activated. And the worst part, it's coming back in 2032. When astronomers first examined the data, they expected to find a familiar pattern, just another harmless rock passing through Earth's neighborhood. But within minutes, something felt off. The asteroid's brightness, speed, and direction didn't match typical near-Earth objects. It wasn't drifting past our planet. It was slicing through space on a path that intersected both Earth's orbit and, alarmingly, the Moon's. The automated system flagged the object with an urgent alert that immediately spread through observatories worldwide. This mysterious intruder was soon designated 2024 YR4, a name that would become synonymous with one chilling phrase: the highest impact risk in recorded history. Initial trajectory models were run again and again. Hundreds of simulations using different datasets, different atmospheric assumptions, different gravitational parameters. Yet every calculation pointed to the same message. This wasn't a statistical fluke. The asteroid truly carried a collision probability never before seen in planetary defense records. Not 0.01%, not 0.1%, but over 3%. To the general public, that number may seem small. To scientists, it was a deafening siren. Planetary defense protocols worldwide trigger at 1%. Anything above that is considered a potential global emergency. A 3% impact probability meant something extraordinary. The cosmos had presented Earth with a threat so real that specialists were forced to consider worst-case scenarios immediately. Only after several weeks of intense observation were researchers able to determine 2024 YR4's size with some confidence. It measured between 174 and 220 feet, roughly the height of a 15-story building. Not nearly large enough to recreate a dinosaur-level extinction event, but far beyond the size that Earth's atmosphere could safely break apart. In fact, according to impact energy calculations from the University of Western Ontario, an object of this size would unleash a blast comparable to one of the most powerful thermonuclear weapons ever created. Not a regional disaster, not a local tragedy, but the destruction of an entire major city, instantly. It didn't take long for the media to give it a grim nickname, the City Killer Rock. But the story soon took an unexpected turn. After 2 months of refined measurements and recalculated orbital paths, the terrifying impact risk with Earth dropped dramatically. Researchers breathed a collective sigh of relief until they noticed a disturbing new trend in the data. The asteroid's updated trajectory didn't place Earth in the crosshairs anymore. Instead, it showed a direct intersection with the orbit of the Moon. And this time, the probability wasn't decreasing, it was increasing. By early 2025, the numbers were undeniable. 2024 YR4 now had a record-breaking 4.3% chance of striking the Moon during its 2032 close approach. A lunar impact of that magnitude would be the most powerful in 5,000 years, and the consequences for Earth, for spaceflight, and for the future of human missions beyond our planet could be catastrophic. Astronomers around the globe realized something unsettling. Earth might have avoided the first threat, but humanity was still far from safe. To understand why 2024 YR4 became the most dangerous asteroid ever recorded, we need to look farther out, beyond Earth, beyond the Moon, into the chaotic region between the orbits of Mars and Jupiter. This is the main asteroid belt, a sprawling graveyard of ancient planetary fragments, home to millions of objects ranging from microscopic particles to city-sized worlds. It is here, in this turbulent region, that YR4 began its journey. At first glance, YR4 seems like just another modest rock drifting among countless others. But astronomers soon realized something unusual about its trajectory. Unlike most asteroids whose orbits remain stable for hundreds of thousands of years, YR4's path had been violently altered. At some point in the recent geological past, an enormous gravitational force had yanked it out of its relatively harmless orbit and flung it toward the inner solar system, directly into our celestial neighborhood. That gravitational force was Jupiter. Often called Earth's cosmic shield, Jupiter's immense gravity does protect us from many potential dangers. It captures or redirects countless space rocks before they ever approach the inner planets. But what most people don't realize is that Jupiter can also play the opposite role. It can eject asteroids from the main belt with extraordinary precision, sending them hurtling inward on long looping trajectories that cross Earth's orbit. This appears to be exactly what happened with 2024 YR4. Simulations conducted by multiple research teams show that YR4's orbit was dramatically elongated after a close encounter with Jupiter. Instead of circling the Sun in a stable loop, it was pulled into a path that now slices through the inner solar system every 4 years, placing Earth and the Moon in its potential firing line. But even more disturbing was what astronomers discovered after its first observed pass in 2024. The asteroid had come within 515,000 miles of Earth, less than 3 times the distance to the Moon. That was when telescopes around the world realized something was wrong. The asteroid wasn't behaving like a typical near-Earth object. Subtle gravitational nudges, particularly from Jupiter and the Sun, were altering its orbit more dramatically than expected. When astronomers recalculated its future path, they found no imminent threat for Earth's next close approach in 2028. But the following pass, expected in 2032, told a dramatically different story. YR4 wouldn't be a danger to Earth, but it would be dangerously close to the Moon. And this is where the story becomes even more unsettling. Most people assume that a lunar impact is harmless, a distant fireworks show with no consequences for us. But researchers quickly warn that this assumption is dangerously wrong. An impact of YR4's size on the Moon, an airless world with no atmosphere to weaken the strike, would unleash a blast equivalent to millions of tons of TNT. It would tear open a crater a mile wide, ejecting enormous amounts of debris into space. Most of that debris would fall back onto the Moon's surface over the following days, but a small fraction, 0.2%, according to preliminary models, would be launched toward Earth. Millions of pounds of lunar rock fragments traveling faster than bullets would enter the atmosphere. They would burn up harmlessly for us on the ground, but not for the machines, spacecraft, and astronauts operating beyond our protective air. For the first time in decades, scientists realized that a lunar impact could trigger a chain reaction capable of crippling satellites, endangering space stations, and choking Earth's orbital environment with debris. And yet, the worst part is this: for the next 3 years, astronomers are effectively blind. YR4 is too small and too distant to track. We must wait until 2028 to learn whether the situation is stable or whether the 4.3% lunar impact probability is only the beginning. If 2024 YR4 collides with the Moon in 2032, the event would be unlike anything humanity has ever witnessed. Unlike Earth, the Moon has no atmosphere, nothing to slow, weaken, or fragment the asteroid before impact. YR4 would strike the lunar surface at full cosmic velocity, releasing an explosion equivalent to 6 million tons of TNT, roughly 400 times the bomb dropped on Hiroshima. Astronomers estimate that the impact would carve out a crater at least a mile wide. On Earth, such an event would unleash a fireball, shock waves, atmospheric disruptions, and potentially global consequences. But the Moon is silent, airless, and barren. So what makes this impact so dangerous? The danger comes from what follows. The explosion would blast a massive plume of lunar dust, molten rock, and shattered debris into space. Most of this material, nearly 99.8%, according to current models, would fall back to the Moon's surface in the days after the impact. The Moon's gravity may be weak, but it's strong enough to reclaim nearly all of its ejecta. But the remaining 0.2% is the problem. That tiny fraction translates into tens to hundreds of millions of pounds of lunar fragments flung outward on trajectories that intersect Earth's orbital space. And while these fragments would burn up harmlessly in Earth's atmosphere, they would not burn up before passing through the region where satellites, spacecraft, and astronauts operate. This is where the scenario becomes truly dangerous. The debris would be traveling at 22,400 miles per hour, faster than most bullets. At those velocities, even a pebble-sized fragment could puncture a spacecraft, cripple a satellite, or threaten the lives of astronauts in any station still orbiting Earth. By 2032, the ISS may be retired, but the Chinese Tiangong station and any new stations will still be vulnerable. And that's only the beginning of the problem. A wave of high-speed debris slamming into satellites could trigger collisions, which then create more debris, which then destroy more satellites, a catastrophic chain reaction known as the Kessler syndrome. In the worst-case scenario, this could render Earth's orbital environment so filled with shrapnel that spaceflight becomes nearly impossible for decades. GPS systems, communications networks, weather satellites, everything we rely on could be at risk. And all of it would begin with a single impact on the Moon. But as alarming as the lunar scenario is, it's not the darkest possibility, because any small gravitational disturbance, especially during YR4's trip near the Sun, could bend its path just enough to send it somewhere far worse than the Moon, straight toward Earth. If 2024 YR4 veers even slightly off course, just a fraction of a degree, its new trajectory could bypass the Moon entirely and set it on a collision path toward Earth. And unlike the Moon, Earth does not offer a silent, empty surface waiting to be scarred. Here, the consequences would be immediate, explosive, and unimaginably destructive. The first question scientists ask is simple. Would YR4 burn up in the atmosphere? The answer is equally simple: no, not even close. Objects below 115 feet wide typically disintegrate before reaching the ground, but 2024 YR4 measures 174 to 220 feet, far beyond the limit. At this size, the asteroid would survive atmospheric entry. The only uncertainties are whether it would explode in an airburst like the 1908 Tunguska event, or strike Earth directly like the impactors that shaped ancient craters across our planet. Either scenario would be catastrophic. When YR4 enters Earth's atmosphere, its speed would exceed 38,000 miles per hour, roughly 10.5 miles per second. At that velocity, the asteroid would compress the air in front of it to extreme temperatures, hotter than the surface of the Sun. If it enters at a steep angle, it would reach the ground in under 10 seconds. Imagine that. a city sees a fiery streak rip across the sky, and in the next breath, everything changes forever. To understand what YR4 could do, we look back to Tunguska. That asteroid, similar in size to YR4, exploded several miles above Siberia, flattening 80 million trees across 830 square miles. The blast was so powerful that it registered on seismic stations around the world. Its shockwave shattered windows hundreds of miles away. For nights afterward, the sky glowed as if it were on fire. But Tunguska struck a remote, uninhabited forest. YR4, on the other hand, could strike anywhere. Millions of potential impact points across continents, oceans, and megacities. One impact map created when YR4's risk was at its peak showed a terrifying corridor stretching from South America across the Atlantic to sub-Saharan Africa. But scientists warn that if the impact probability rises again, this corridor could shift. A hit could occur in Europe, Asia, North America, anywhere. To illustrate the stakes, researchers simulated what would happen if YR4 struck New York City. The results were staggering. Upon impact, the asteroid would release a blast far more devastating than any nuclear device ever detonated. Without the radiation, a crater over 1 mile wide would obliterate everything within a 2-mile radius. Midtown Manhattan would cease to exist. Iconic structures like Times Square, the Empire State Building, and Grand Central Terminal would be erased in an instant. The surrounding boroughs would fare no better. Brooklyn Heights, Williamsburg, Long Island City, all would be ravaged by shockwaves capable of ripping steel beams apart and collapsing high-rise buildings. Bridges would crumple, roads would buckle, fires, massive, uncontrollable fires, would ignite across the city. As the firestorm spread, the heat could ignite structures miles from the impact site. Within minutes, hundreds of thousands of people would be caught in the inferno. Within hours, millions would be affected by falling debris, collapsing infrastructure, toxic smoke, and grid failure. But the devastation would not be contained to one city. The shockwave would ripple across the region, shattering windows as far as New Jersey and Connecticut. Air travel would halt instantly. Power grids could fail. Communication networks would collapse under the strain. And beneath the impact crater, deep within the crushed layers of rock and debris, the blast would trigger violent seismic waves. Earthquakes, potentially reaching magnitudes rarely seen in human history, would shake the surrounding region. All of this from an asteroid no wider than a 15-story building. What's worse is the aftermath. If YR4 were metallic, and many asteroids of its size are, it would not fragment easily. Instead, it would strike as a single catastrophic blow. The dust it throws into the atmosphere could linger for days, darkening skies and disrupting weather systems. Fires would rage for miles. Emergency response capabilities would collapse. Hospitals would be overwhelmed. Food and water supplies would be disrupted. Cities don't just rebuild after an event like this. Civilizations struggle to recover. No wonder planetary defense specialists are already calling YR4 one of the most dangerous asteroids ever recorded, even with Earth's current impact probability reduced to near zero. Because the story of YR4 is far from over. The asteroid is still on approach, its orbit is still unstable, and the year 2032 is getting closer with every passing second. Even with the terrifying scenarios scientists have modeled, one fact remains reassuring. Humanity is no longer blind to threats from space. We now possess the technology, coordination, and understanding to track, analyze, and, if necessary, attempt to intercept objects like 2024 YR4 before they collide with Earth. But here's the truth few people fully grasp. We have never stopped an asteroid before. Not once in human history have we deflected, destroyed, or redirected a real cosmic object on a collision course. Our first experiment, NASA's DART mission, successfully nudged the asteroid moonlet Dimorphos in 2022. But Dimorphos was tiny compared to YR4, and the impact was carefully planned. YR4 is different, bigger, faster, unpredictable, and unlike the DART target, this asteroid's orbit is chaotic, constantly shaped by the gravitational influence of the Sun, the Moon, and especially Jupiter. Every small deviation in space could add up to a major shift over the next decade. That's why missions targeting YR4 must be strategic, timely, and executed with unprecedented precision. Scientists have proposed a bold plan known as Plan B, launching a nuclear warhead aboard a spacecraft designed to detonate just above the asteroid's surface, not to vaporize it, Hollywood style, but to shatter it into smaller fragments that would burn up safely in Earth's atmosphere. According to preliminary calculations, the warhead would need to be at least 50 times more powerful than the one dropped on Nagasaki. It's a strategy with enormous risk. A premature detonation could scatter dangerous fragments across space. A delayed detonation could miss the target entirely. And worst of all, a failed launch could leave humanity with no time for a second attempt. That's why timing is everything. Between late 2029 and the end of 2031, YR4 will move into a region where an intercept mission is theoretically possible. But if astronomers wait too long or miscalculate its position, the opportunity could vanish. And by the time YR4 approaches again in 2032, it will be far too close for intervention. Yet despite these uncertainties, there's reason for hope. By 2028, when YR4 returns to our cosmic neighborhood, astronomers will finally regain visual contact. Only then will we know whether the asteroid's lunar impact probability, now sitting at 4.3%, the highest in recorded history, is stable, decreasing, or rising. We may learn that the moon is safe after all. Or we may discover humanity has only a few years to act. Either way, YR4 has become a cosmic reminder of something humanity often forgets. We live in a universe that does not bend to our expectations. A universe where danger can emerge suddenly, silently, without warning. Where a rock the size of a modest building can threaten everything we've built. But also a universe where intelligence, cooperation, and scientific courage can turn fear into action. So now the question shifts to us. Will we be ready? Will we respond with unity and determination, or complacency and disbelief? And when 2024 YR4 returns, whether as a harmless traveler or a looming threat, will we have the strength to face whatever its orbit brings? Because the countdown has already begun. The clock is ticking toward 2032, and the next move is humanity's. What do you think will happen when 2024 YR4 returns in 2032? Do you believe its impact risk will rise, fall, or reveal something even more unexpected? Share your predictions in the comments below. I read every one. And if this episode opened your eyes to the real dangers hidden in our cosmic backyard, make sure to like, subscribe, and join us for the next journey into the universe's most mysterious threats.